equation that's dy over dx equals, or you might have something that looks like dy equals 2x dx. That's an example of a differential equation. But normally when we start out, we have dy over dx. Remember when we did slope fields? Slope fields were pretty easy for us to graph, but a lot of those slope fields had those x and y in the value that we had to graph. You had to plug in both the x and the y value. Now, up to this point, when we found antiderivatives, we've only done it in terms of x. But now we've got two variables we have to integrate. And so what we can do is called separation of variables. And it's not a difficult concept. We have this differential equation, dy over dx equals 2x over y. So what I want to do is group everything that's got y together, including the dy, and group everything that has x together, including the dx. So to do that here, I'm going to multiply, cross multiply. This looks to us like a proportion. It's a differential equation, but we can kind of think about solving it like a proportion. We would have y times dy, they don't all work that way, but this one would, equals 2x times dx. Questions on what I just did? Group your y's, group your x's. Sometimes you can do it by cross multiplying. Sometimes we may have to do a little bit more manipulation. All right, so when you are asked to solve for a differential equation, that means you want it y equals. Your final answer should be y equals. That's what it means when it says solve this differential equation. Y equals. Yes, sir?
Would there ever be what would happen if you had a constant?
You would still integrate it. You mean
like
2 over y?
Yes. Or no, like if you had like 2x minus 1 over y, would you just take the negative?
You'd do the same thing. You'd multiply 2x minus 1 times dx. All right, now what we want to do is integrate both sides. We have really, even though we didn't talk about it too much, we were always integrating
Well, can you just
dy.
integrate both sides at the same time?
Do what?
Can you just integrate both?
Yes. We always did it. When we had dy equals the integral of something, when we solved it, we were actually taking the integral of both sides to get y. But this time we have an extra y here. So we're going to integrate this just like we would an x. What's the antiderivative of y going to be?
Y plus c.
Y squared over 2. Yay. There is a plus c. We'll go ahead and put it this time. Equals, what's the antiderivative of 2x? X squared plus c. And it's a constant's a constant's a constant, right? So if I move that c over, if I subtract it, I'd still get c. So we have y squared over 2 equals x squared plus c. I want to solve it for y. So Michael, what can I do? Schwarzbach.
Oh, you multiply both sides by 2?
Multiply both sides by 2. And 2c is still c. And so if we solve it for y, we would have, well, y equals plus or minus the square root of 2x squared plus c. So that is a general equation. Questions on what I did? You okay, Nan? All right, fine, maybe. Okay, this is a general solution. When we remember if we don't have initial conditions or we don't have limits, then it's a general solution. But if we have initial condition, 1, negative 3, I can figure out what c is. So we can just plug in, if y is negative 3, is it going to be plus or minus the square root, or just the positive, or just the negative, or can we tell? You're feeling a positive? Okay, let me ask you something.
It should be a positive, it could be a negative.
Not be positive.
No.
Could
No,
be
it
negative?
It could be both,
No, it
because
could be
it's
both
squared,
because it's
so
squared.
it'll, either way it'll be positive on your
Not be.
Okay, but if the square root is equal to a negative 3, is it the negative root or the positive root?
It's the negative.
The
It's going to have to be the negative root. Okay, let's talk about that again. If I plug in my 1, I have 2 plus c. Okay. In order for this to be negative,
Whoa,
this has to be negative, doesn't it?
yeah.
Yeah, that's how we know it's the negative, because we got a negative y value. If we had a positive y value, we'd be taking the positive root. All right, so if we square both sides, yeah, that part now does look positive. What is c? So y equals, and that, I know that doesn't look like a y. Why won't it won't erase? I know. Y equals a negative square root of 2x squared plus 7. Okay, now this one doesn't look so much like a proportion, does it?
No, it doesn't.
But we still have to group our x's, and we still have to group our y's. So we know we're going to be multiplying by dx. How do I get y to the other side? Divide. So we're going to have dy divided by y squared equals 4x dx. And if we take the integral of both sides, I could rewrite this if it's helpful. Y to the negative 2 dy. And if you want, you can pull the 4 out. You don't have to, but you can pull the 4 out. Okay, so when we integrate y to the negative 2 dy, Jen, what do we get?
What was your?
If I integrate y to the negative 2,
It would be negative y to negative 3.
to the negative 3, okay, negative 1 over y. Y to the negative 1, you add. So it's the same as negative 1 over y, right? Y to the negative 1 is 1 over y. Do I need to put my plus c here?
Sure. No.
I don't have to. It's not wrong if you do, but you don't have to put it right there. Annalisa, who's it for? Grace is not here.
This happens twice.
Okay. What do we get here? 2x squared plus c. Okay, in a case like this where we have y in the denominator, it's probably going to be easier to find our c right now and then solve it for y. All right, so what's our initial condition? When x is 1, y is 3, so we would get negative 1/3 equals 2 plus c, and subtract 2 from both sides. How many thirds is 2? 6 thirds. So negative 1/3 minus 6 thirds is because there's our C. Okay, you can't leave, so we come back and plug it in. We got negative 1 over y equals 2x squared minus 7/3. I don't, does that solve it for y? Nope. So what we've got to do is see what we can do to solve it for y. So let's get a common denominator on the right-hand side. Well, you'll get there eventually, but I'm going to do this first. We get 6x squared minus 7 over 3. Is that right? Okay. And if I multiply everything by negative 1, that happens. Now we can do what, Matthew?
Switch.
What do you mean by switch them?
With that one.
And what do we call that when we do that? Reciprocal. Well, tides. Y equals 3 over 7 minus 6x squared. So there is your equation. And that equals to what?
Write it down
Whoa. I think it's.
Oh, sorry. What?
Add 1 to the exponent.
What did we do for 6?
Divide it by x cubed over 3.
Yes.
Yeah,
Oh, never mind. I got it. Sorry.
Okay.
when do you subtract?
What?
When do you subtract?
When do I substitute? Right now.
You say add 1.
Uh-huh. Hang on just a minute. Okay. Shh. Are we ready to go on? All right. So now we can plug in our information, right? We have the natural log of negative 5 equals C. Now here's the fun part. The natural log of y equals 2x cubed. Let's just leave it as absolute value of negative 5 for right now. Even though once you take the absolute value, we know it's going to be positive 5, but it's going to make a difference in the answer when we solve for y. Because this has not solved for y, has it?
Wait, so why can't it just be only 5?
Because it's going to make a difference when we solve this for y.
But isn't that going to be the constant?
Negative 5 will be part of it. No, not right now.
But the constant would stay the same, right? So it could be.
But we can't leave our problem like this. So let's finish it. And then I think you'll see why we have to leave it as the natural log of negative 5. Okay? So how do I get this y from here by itself? E everything. Or rewrite it in exponential form or exponentiate both sides. That's what you just did on your homework. So e to the 2x cubed plus the natural log of the absolute value of negative 5 equals y.
So can you just make that negative 5 now?
We okay here?
No.
Why not, Josh? What's wrong?
Nothing is okay. Everything is
Matt.
bad.
Josh, what's your question?
Let's see.
How did we set C equal to ln?
Okay, my initial condition was when y equals 0, when x is 0, y is negative 5. So I just plugged in -5 for y and 0 for x.
That's it?
That's it.
So e to the ln of absolute value of y is just y?
Yes, we just rewrote this in exponential form. E to this equals this.
But and then down there doesn't have to be the absolute value?
I do have the absolute value of -5.
But
No, that does not have to be absolute value.
Okay.
Okay, so let me come up here. Oops. I can rewrite this as e to the 2x times e to the natural log of the absolute value of -5, and that equals y.
But can you do that?
Wait,
Yes, you
What
can.
happened to the 2x cubed?
it should be cubed.
Oh, did I?
2x cubed.
It should be cubed, yes, thank you. Okay, when we multiply the same base together, what do we do with exponents? Add your exponents. I just went backwards.
Why did we do that?
Because now, e raised to the natural log of the absolute value of -5 equals -5. There you can make it -5.
I've done it.
There is your
Wait.
equation. Y equals -5 e to the 2x cubed.
Well, how?
We want to solve this differential equation that's in x and y, and we're given an initial condition of when x is 1, y is -5, so my initial condition is the point, 1, -5. How can I separate my variables here?
Take out 4x cubed.
What'd you say, Emily?
Take out 4x cubed.
Factor out of 4x cubed. And that gives me
4x cubed.
y plus 3. So now it's easy to separate the x's and the y's. We'll have dy divided by y plus 3 equals 4x cubed dx. Now what?
Take the
Antiderivative. And what is the antiderivative of dy over y plus 3, Daniel?
Yes, there it is. The natural log of y plus.
Thank you, Daniel. Is he right?
I don't think so.
You do or don't? You don't think so? What do you think it is? Do we have the derivative of the denominator in the numerator? So, he's right. It is the natural log of y plus 3. Equals
X to the 4th plus C.
x to the 4th plus c. Non, what's the next step? Put it in. Okay, what about my c? I need to know what c is. How do I find c? Put in the numbers. So we get the natural log of what? Equals. Will that work for C? Okay. So we have the natural log of y plus 3 equals x to the 4th. I'll go ahead and move that over. It doesn't really matter. Natural log of negative 2. You can do the minus 1 last if you want, or you can move it over.
Now you gotta eat it.
Now we e it. Okay, so if we e it, we get e to the x to the 4th minus 1 plus the natural log of the absolute value of negative 2 equals y plus 3. And we can rewrite this. It's e to the 4th, or x to the 4th minus 1 times e to the natural log, the absolute value of negative 2 equals y plus 3. And what is e to the natural log of the absolute value of negative 2? Negative 2. So we're going to have negative 2 times e raised to the x to the 4th minus 1 minus 3 equals y.